Next step in the design process that we're going to look at is concept selection. And we've talked last time about concept generation, where we tried to break the problem down by doing a functional decomposition, determining all the functions for the project. And we looked for solutions, and we tried to explore all the different options that we could get for those functions. And then we kind of compared some of those concepts against our specs. We tried to rule out some of those concepts. You could update your specs after that point, but we were trying to move on with some concepts that met our specs. So in the selection process, what we want to do is take some of those design ideas that seem the most promising, some of the best ideas for each function or each concept, and we want to compare those together against each other using some criteria. We're going to use our specs that are written as goals to help make that decision. We're going to use something called a decision analysis in the process of doing that, and also in this process we could update our specs and make new specs if we needed to help us make a decision. And we want to, in the end, we want to pick out the best concepts that we can use for each goal, and maybe the overall best concept in the end is what we're looking for in the end, which is a combination of different concepts for each of those functions. Our final design selection will then take place where you make your final selection on which design or which parts of the design you're going to proceed with. You can make refine those. We could make revisions to those. We can do a lot of engineering analysis to try to size things, make sure it's going to be the right size so that it's not going to break, and we want to make sure that it doesn't violate any of our specs. We can go back and check our design against our specs that we have, and we want to in the end make sure that the design that we've chosen makes sense too, that we trust what it says before we go ahead and try to implement the design. That's where it gets expensive to make changes at that point. So the concept selection process in general talks about narrowing down the number of concepts. That's kind of what we'll be looking at, trying to come up with from a lot of ideas down to fewer ideas that we can consider to go further on. We're looking to converge to a single idea in the end, and we can always go back and we can combine ideas together to get new ideas, and we can always generate more concepts along the way and then evaluate those also. We want to evaluate the concepts that have passed the specs that are listed as constraints, the criteria that it has to meet. If it doesn't meet those, we don't need to really consider it at this point because it doesn't meet those specs. We can throw those ideas out. And we want to be able to compare them to each other. We're going to be using our goals to do that, and we want to be able to quantify that in some way, look at some type of evaluation in the process of doing that in order to rank those ideas. So in general, kind of a visual to what's going on. We're starting with a few different goals there. Goal 1, 2, and 3 I just have listed here. And each of those goals or functions to the design has specific concepts that seem promising that we want to proceed with. And if you take those and you kind of combine them together in different ways, we can combine them into overall combinations that we can evaluate and look at in order to determine which of those is going to be the best overall design. And that's how we kind of narrow down the process. So we want to be able to take those best ideas that we generated in our concept generation stage. We want to only pick out concepts that satisfy our specs. And we want to be able to review these specs at this time too and make sure that we haven't missed anything. If any of the specs need to be revised because maybe they're not helping us make decisions correctly. And we want to be able to go on and use something we're going to call decision tables or decision matrices. And we'll use some weighting factors that we can try to justify using some of our customer needs and overall needs of the design in order to analyze those with those tables. Just that there's a lot of different kind of processes that you can go through in the design selection process, and we're going to focus on one, but there's a whole bunch of other ideas out there on factor balancing, and you could look at trying to write a program to help you make decisions, which is kind of a structural process. There's decision trees where you look at branches coming off or making different decisions along the way, and each one has a certain cost effect in the end. There's a cost and risk analysis process, which is another method that's commonly used, and a fuzzy set, which is kind of using some programming language and things like that to help you make decisions and choosing between lots of different combinations of ideas. So they're all different processes that you can use that are structured, but we're looking for something that we can probably use a little bit easier right now. And what we're looking for is a nice structured process to help us approach our selection process. So the benefits for using a structured approach is that we're trying to make sure it's focused on the customer needs. That was one thing we started from the beginning. We have these customer needs that we want to be able to try to meet. It helps us when we're benchmarking that we're going to be able to get a competitive design that's going to be a good design, and it helps work out some of the processes between designing the product and getting it made. As in the manufacturing process, it helps move that process along easier. It helps us reduce the overall time because we have kind of a process set up that we can follow that process, and we can go from the concepts to implementing it a lot faster. And it helps the team make a decision better, helps everyone come to an understanding of why we're making a decision the way we are, and everyone has a consensus in that solution so that everyone agrees that that's the best way to approach it. It also gives you a way to document your process along the way, so you can prove to your boss or some other team that you've had a reason why you made decisions. And there's usually numbers involved in this process, so engineers are a little more comfortable with that. So it helps us make decisions based on some quantitative evaluation. So we're going to look at a process or a methodology that we're going to go through 2 stages. The first stage is looking at a screening process to try to eliminate some ideas. If you have a large number of ideas and you want to do a real quick evaluation of them and get rid of some of them and narrow it down to just a few. And then after that point, you can do a concept scoring process where you're trying to look at the importance levels of different criteria and helping make decisions with that. And I'll explain those later on. Some things to watch out for, some caveats with concept selection, is that sometimes when you're looking at the overall concept, you're picking out the best idea for each function, and when you put them together, it doesn't always come up with the best overall solution. Sometimes there's a lot of interaction between some of the criteria that you're not really catching when you're looking at piecing together different good ideas. Sometimes the subjective that we're using, or some of the criteria that we're using, is subjective. Sometimes it helps to get some input from a customer. Could be an opinion-based thing, but helps you make a decision better if it's based on a customer need. And if it's something that's not quite as subjective, you can get some numbers to it. It helps. Also, we must sometimes include factors that we didn't consider from the customer, such as like how is it going to be made. The customer usually is not concerned about that. So those are things we had to watch out for, that we don't miss those along the way when we're making decisions. We can look at either individual subsystems and then try to piece them together, which may be a good idea, or you can look at different functional concepts that are pieced together to get an overall concept and then evaluate individual concepts. So we can approach our decision process that way too. Either way, we could go in that step. So overall, though, concept selection, it's a method, it's a tool that you have that helps you make decisions, helps your team come to a consensus. But in the end, you still have to use some of your judgment, using your engineering knowledge to help make sure you've picked out the best solution. So hopefully this will help you in your process of selecting out concepts for your design.